Hello, everyone. In this part of lesson, I would like to, lead you guys to homework, working on homework. We have these, derivative rules already, okay? And we also have learned, we're not working on these two this lesson. The derivative of trig functions. Okay, we have these derivative of trig functions and those other power rules, addition, subtraction, multiplication, division rules, and the power rules, e to the power x derivative, and so on and so forth. So now we're ready to tackle these derivative rules. So I'm going to choose some questions from this section to follow, to work with, and I want you to follow me. Okay, so the first one, obviously, is usually the simplest one. So we start from the simplest and apply the product rule. Okay, so x squared sine x, right? So if we still need some guidance on power rule, so pull out your, flashcard next to it so we can start working. Okay, so now we have, we're going to continue to work on it. The derivative of f of x in this case is equals to, so differentiating x squared, that's 2x, not doing anything with sine x, plus differentiating sine x and not doing anything with x squared. The derivative of sine x is a cosine x. We're done. We're finished, right? So this is a direct application of product rule along with the derivatives for trig functions. Number two, I know those are optional, but sometimes once in a while, we do some negative, even number. It's also delightful, okay? Plus 2 times tangent x. And the derivative of this new function, why did I get that? Okay, sorry. F of x, okay? So you can see the first part is the power rule and plus another part. So we have to do it separately. So on this piece, we're going to do power rule. So we're differentiating x, which is equals to 1 times, the dot is optional, but just leave a little space, and x, the derivative of cosine is negative sine. So by this time, we're not done, okay? We just differentiated this product. We also have to differentiate 2 times tangent x. So 2 is a constant, we leave it out, right? And tangent, the derivative of tangent is secant square x. Okay, we're almost done. You just do a little trimming. The trimming I meant that 1 times cosine is same, negative, positive. So this whole thing is going to be minus. We can remove the parentheses. It's finished, right? Simplifying these, okay? And I think for this question, we're done. We are finished. Okay. The other one I would check with is number 6. Okay. G of theta. See, we use a slightly different variable from x, right? So we're not always using x. When we are not using x, and you know what we're doing. Okay. So e to the power theta multiply tangent theta minus theta. Okay, so now we're going to differentiate g with respect to theta. So this is a product rule. This is a product rule. Okay, so you're going to treat this as F parentheses as G. Okay, so product rule. We first differentiate e to the power theta. E to the power theta being differentiated, it's the same as e to the power theta. And the other parts stay the same, no change, plus keep e to the power theta and differentiating the numerator. I'm sorry, differentiating inside the parentheses. The derivative of tangent is secant squared. The derivative of theta with respect to theta is 1, minus 1. So we are pretty much done. But if you want to reduce it, you can use some, you can use your knowledge about trigonometry to simplify it. Okay. At this stage, I will accept this one as the answer. But knowing that we are going to do more in chapter 4 on these things, I'm just going to give you a little more work that may give you a glimpse of it. So e to the power theta will be factored out, right? And inside here, we have tangent theta minus theta plus all of these in parentheses. So I'm going to bring them together. Is there anything I can do to reduce it? The only part I think we can reduce is secant squared, theta minus 1. Why? Because we know there's this identity here, right? So 1 plus the tangent square theta is equals to secant square theta. Okay, so now we got secant square theta, right? So I mean, this is my think out aloud. So I'm working on this is my sketch paper. So from this part, right, I have a secant square theta minus 1. So from this identity, I will get a tangent square theta equals to secant square theta minus 1. So on this step, I'm going to replace this piece by tangent square theta. Then you say, what's the use of it? There might be some use of it, okay? But that's the simplest we can get. That's the simplest we can get, okay? So once again, for the purpose of current chapter exam or quizzes, up here, this up here, that will be an acceptable answer. You don't need to go further. All right? So let's choose another question, which is number 9. Let's look at number 9. Number 9, we got x over 2 minus tangent x. We're going to differentiate this function. Obviously, quotient rule. So dy dx, we're going to apply quotient rule, okay? You should have your quotient rule card with you if you don't remember, okay? The denominator being squared, okay? Differentiating the numerator, which is 1 multiply denominator, right? Subtracting, we keep the numerator, differentiating 2 minus tangent x. Derivative of 2 is 0. Derivative of tangent is secant squared. Okay, you can omit the 0 if you want. And now what do we got? 1 times that can be omitted. 0, subtract that, it can be omitted. These two, negative sign, that makes positive, right? So we got to this part. Can we reduce it any further? I doubt it. I don't think we can do much. Okay, so this step is essential, okay, or that, and you're done. You're finished, right? So it's not that scary after all. Okay. Let's choose between 11 and 12. How about I do 12, you do 11, right? I do 12, you do 11. So y equals to cosine x over 1 minus sine x. Differentiating. So we got dy dx, right? Dy dx. Oops. Apply quotient rule. Apply quotient rule. Denominator 1 minus x, right? Squared. Numerator, the derivative of cosine is negative sign. Multiply the numerator. Subtracting, we keep the numerator and differentiate the denominator. Differentiate denominator 1 minus sine x. That's going to be 0 subtracting cosine x. Okay, let's see if we can simplify that. 0 minus that, right? Negative cosine x times negative cosine x, that makes cosine x squared, and that's going to be plus, right? So that part, this part altogether give us cosine square x. How about the front, the earlier part, right? We're going to take a negative sine x to multiply 1, right? To multiply negative sine x, right? We take a negative sine x to times 1. We get these. We get that, right? So this is just be negative sine x, and negative of negative sine x times sine x. Obviously, we're getting something interesting here. So it's a plus sine x squared. So squared. Okay. All right. Now, what do we get? Sine square x plus cosine square x equals to 1. Okay, so that's a 1. We got something similar on numerator and denominator, isn't it? So if I bring this 1 to the front, which I can, commutative property, we get 1 minus sine x over 1 minus sine x to power 2. We can reduce it provided, of course, we do everything in the domain. Right here, it's not asking for domain, so we're doing everything in the domain. So we got that answer. That's the answer. Okay. So if you can see in some situation, it can be reduced. It can be reduced quite a bit. It can be reduced quite a bit. So this is the opportunity for us to gradually review our trigonometry. Okay, if you need help, please don't hesitate to reach out to me. And I will leave some of these questions to you, but the last but not least, I'm going to give you some hint about 15, and we're going to do 15. Let's do 16 first, and then I'm going to do 15. Okay, so f of t equals to t times e to the power t cotangent t. We got 3 factors. How we're going to differentiate that? How we're going to differentiate that? Okay, no fear. We can do it. Okay. The product rule is for 2. We don't have product rule for 3 factors, even though we can derive it. We can derive it, but it's not necessary. We don't need another formula. We really don't. Okay. We have too many formula already. All right. So now what we do is we're just going to apply the product rule we know, right? And we're going to set it up. So we're going to treat this one as one function, right? So we're going to do, we're going to differentiate that part. Cotangent T plus, we don't change anything about the first, parentheses, and we just differentiate a cotangent T. What is the derivative of a cotangent T? We have the formula right here, right? It's negative cosecant. So this is our first round, okay? But you can also say, okay, I'm going to do this together. No problem. You can do it together because we can plug in here. This is just going to be a negative cosecant squared of t, sorry. Okay, so this part is done. How about this piece? This is going to have to apply product rule. You could have applied a product rule over here already, when you do it over here. Okay, so I'm going to put a bracket so I have more space to take care of the product rule here. So the derivative of t is 1 e to the power t, right? 1 times that, plus the t and differentiate e to the power t. So keep the t differentiating e to the power t. E to the power t differentiated with respect to t is still e to the power t. So this part is being taken care of, which is in the bracket. All right. So now simplify. Let's see how much we can simplify. This is 1. This is t times that. And this is a negative sign, so we can put a negative sign in front. And we can drop the parentheses, even the dots, right? We can even change this to parentheses. You can take out all of the e to the power t, actually, if you want. But we are pretty happy as is. We're pretty happy as is. Okay, so last but not least, I promise you I'm going to do 15. So f of theta is equals to theta multiply sine theta cosine theta. Okay, we have 3 terms this time. But this time we can get around it. We don't have to use what the method we did earlier, because we have a trig formula. Okay, this trig formula is double angle formula. Okay, so sine 2 theta is equals to 2 times sine theta multiply cosine theta. I would use this. You can still do what we did on number 16, but I'm going to do it this way. Okay, this way, sine theta over cosine multiply cosine theta equals to half of sine. Oh, wait a minute. We need to do this at chain rule. Never mind. Okay, so when we learn chain rule, come back to do this question. Okay, we're not doing chain rule for now, so we're gonna have to do the 3. I'm so sorry, but that's okay. You got it. So try this question. Remember this question? Try this question after we learn chain rule. Okay, after we learn plane rule, okay? All right, so we still have to do the 3 parts, but no big deal, okay? No fear. Derivative f prime of theta equals to, right? So you either make these two or the other two. Really doesn't matter. You can combine them any way you want. So I'm going to differentiate this piece, okay? And the derivative, cosine theta plus, and I keep that part and differentiate cosine theta, right? So I'm going to differentiate that part. All right. How about this piece? This piece, we're going to have to deal with it, right? Differentiate theta, we get 0. I'm sorry, 1. Sorry, 1 times sine theta plus theta multiply derivative of sine theta cosine theta, right? Plus, we're taking care of this part. Theta times cosine theta. Oh, theta times sine theta, sorry. The derivative of cosine theta is negative sine theta. Negative sine theta. Okay. Double check my product rule, differentiate theta, differentiate the cosine, differentiate sine theta, got cosine theta. Okay, we're good. Continue to reduce. So this is one time that we can drop the parentheses here. That is a negative sign, negative, right? Remove that. And sine square theta. So sine square theta. So we're gonna put it here. And we're finished, we're done, okay? But don't forget, okay, you can do all of these. And as you can see, if you follow me, you have already done it once, and try one more time or 2 more times until you can do it all by yourself. And this is also the perfect opportunity to review our trigonometry. And if you have any questions, please don't hesitate to reach out to me. And thank you for watching.